Hello everyone, how are you? Hope you all are good and I welcome you all in my new channel and in a new video in which I am going to start the physical chemistry first chapter mole concept and now let's start. So we start with very basic mole concept. It is the first chapter of physical chemistry. Physical chemistry. Okay, now let's start. Matter. We all know that matter is anything that has mass and occupied space. For example, pen, book, smartphone, anything that occupied space and mass, we can call it matter. And now go through classification of matter. Matter are of two types, mixture and pure substance. Now comes to mixture. Mixture is when if more than one type of molecules present in a matter, then it is called mixture. When any more than one types of molecules present in a matter is called mixture. What is pure substance? Pure substance is matter formed by only one type of atom or molecule. जिसमें अलग अलग तरह के मॉलिक्यूल्स हों उसको हम मिक्सचर कहते हैं, और जिसमें एक ही तरह के एटम या एक ही तरह के मॉलिक्यूल्स हों उसको प्योर सब्सटेंस कहते हैं. फॉर एग्जांपल मिक्सचर का फॉर एग्जांपल एयर, जिसमें हमें अलग अलग तरह के मॉलिक्यूल्स मिलते हैं उसको मिक्सचर कहते हैं. और इन प्योर सब्सटेंस हाइड्रोजन गैस एंड सोडियम एंड वाटर, इट इज़ अ प्योर सब्सटेंस बिकॉज इसमें या तो इसमें बस हाइड्रोजन के एटम है, इसमें बस सोडियम के, इसमें बस वाटर के. सो नाउ कम्स टू द classification of mixture. Mixture are of two types: homogeneous mixture, heterogeneous mixture. Homogeneous mixture is when different molecules distributed uniformly in solution. When different molecules जब अलग अलग मॉलिक्यूल्स एक यूनिफॉर्म रेशियो में डिस्ट्रीब्यूट हुए हों तो हम उसको होमोजेनियस मिक्सचर कहते हैं. एंड व्हाट इज हेट्रोजीनियस मिक्सचर? When it does not form uniformly distributed solution. Oil in water, petrol in water, like when the mat mix when mixture when in the mixture the particles are not uniformly distributed, then that solution is called heterogeneous. And its example is like oil in water, petrol in water. जो यूनिफॉर्मली तरीके से डिस्ट्रीब्यूट नहीं होते उसको हेट्रोजीनियस मिक्सचर कहते हैं. नाउ कम्स टू क्लासिफिकेशन ऑफ प्योर सब्सटेंसेस. इट इज़ एलिमेंट प्योर सब्सटेंसेस आर ऑफ टू टाइप्स, एलिमेंट्स एंड कंपाउंड्स. And what is elements? Elements is only one type of atom present in pure substance matter. When only one type of atom present in pure substance, it is called element. And when more than one type of atoms present in pure substance, it is called compound. Like in elements, each for example H hydrogen H2, here two atoms of hydrogen only. O3 ozone, which is also called ozone, here three particles of oxygen only. And now comes to compound. Here CO2, here one atom of carbon plus two atom of oxygen, and it mixes up and make CO2. It combined to form CO2. And in H2O, there's two hydrogen atom and one oxygen atom makes H2O. Matter is what are the states of matter? There are three states of matter: solid, liquid, and gas. Now we come to effect of physical state, and let's see whether mass. And we all know that in mass there is no matter of physical state. Mass is equal in gas, liquid, solid. And when we count number of molecules, it is also does not depend on physical state. For number of molecules, gas is equal to liquid is equal to solid. When we come to volume and density, here it depends on physical state, in which volume of gas is more than volume of liquid and volume of liquid is more than volume of solid. And in density, density of gas is less than density of liquid, and density of liquid is less than density of solid. Now comes to the main part of the chapter, mole. A mole is the amount of substance that contains as many species, atoms, molecules, ions, or other particles as there are atoms in exactly 12 gram of C12 isotopes. 1 mole is equal to 6.222 into 10 to the power 23 species, in which it tells us that mole is the unit of substance like that contains 6.022 into 10 to the 23 particles or atoms or molecules, or it represent a unit of which have the atoms exactly equal to 12 gram of C12 isotopes. And in C12 isotopes have three types of isotope, C12, C13, C14, in which C12 is non-radioactive. 12 grams carbon, 12 isotopes. Let's move it further. Avogadro number is 6.022 in 10 to the power 23. It is same as the 1 mole uh, number of carbon atom, and 1 mole, we all know 1 mole is equal to 6.0222 into 10 to the power 23 number, and 1 mole is equal to Na number. Na is, we represent this number by Na, and here we for shortcut we can use it. And 2 mole here is, we simply multiply it by 2, and we got this number. And when half of mole is equal to Na upon 2 numbers, and 1 mole oxygen atom is equal to 6.22 into 10 to the power 23 number of oxygen atom, and 1 mole oxygen molecule is equal to 6.22 into 23 number of O2 molecule. जो भी हमें पूछा रहता है, मतलब कोई भी पूछा, अगर एटम पूछा है तो उसका 6.22 इंटू 10 टू द पावर 23 नंबर ऑफ एटम ही लिखेंगे. जब मॉलिक्यूल पूछा रहेगा तो important, you have to note down it. And now to another part, relation between number of molecules and moles. For how we can find a number of molecules by moles. When for finding number of moles, we have to divide number of molecules given number of molecules upon Avogadro number, which is basically 6.022 into 10 to the power 23. It is same as it. And here we take an example. Here the CO2 gas have the molecule 6.022 into 10 to the 21, and here upon Avogadro number gives 10 to the power minus 2 mole CO2. And here's the formula. When we divide mole into Avogadro number, we find the given number of molecules, and these molecules depend on mole, what moles of that number. Mole, for finding mole we can also do number of molecules upon Avogadro number. Now comes to the next phase. Just like a compound is given and we have to find the number of mole individually of A and B, then we have to be like use number of mole of A is equal to X into number of mole of AXBY, and for number of mole of B we have to multiply this y into number of mole of AXB. पहले इसका पूरा मोल निकाल के फिर ये x को डिवाइड करेंगे तो हमें नंबर ऑफ मोल ऑफ A मिलेगा, अगर y को डिवाइड करेंगे तो हमें नंबर ऑफ मोल ऑफ B मिलेगा. मोल इन टर्म ऑफ मास. 1 mole is equal to, we all know it, it is very basic for now, 6.022 into 10 to the power 23 number, and number of mole is equal to given number of molecules we studied earlier upon 6.022 into 10 to the power 23 gram. And for mass, number of mole is equal to mass in gram upon molecular weight or atomic weight. And let's see some important formula. Mass upon molecular weight gives us mole, and mole into molecular weight gives us mass of substance, and mass of 1 mole is equal to molecular weight in gram. Also, it is also called molar mass. Number upon Avogadro number equal to mass in gram upon molecular weight. Suppose ax by something given, and now we have to find number of a atom. For finding number of a atom, we have to divide this x into mole of this whole compound, and also with we have to multiply Avogadro number. And for finding b, we have to do the same thing, but we here one thing is to change. Here we have to multiply by y into mole of axby into Avogadro number. And for finding total number of atoms, we have to plus this, add these things, add these subscripts and x plus y, and then we have to multiply as usual into number of mole of axby plus number Avogadro number. And for calculation of electrons, protons and neutrons in molecules, let's see it. Suppose axby is given, and we have to find total number of proton. Then we will do atomic summation of atomic number into atomicity into mole of axby into Avogadro number. For finding total number of electron, we have to do the summation of atomic number into uh, atomicity into mole of axby into Na. And for finding total number of neutron, we have to do summation of bracket में a minus z, a minus atomic number of atoms into में atomicity into में mole of axby into में Avogadro number. Here this zi represent atomic number of atoms and this xi represent the atomicity. Now comes to ions. Ions are of two types, positive ion called cation and negative is called anion. And we all know that total number of protons and neutrons are same in both case, neutral and ions. Okay, now how do we find electron in ions? So let's see. Total number of electrons in cation is equal to cation is equal to summation of atomic number of atoms into atomicity minus n into mole of cation into Avogadro number. Total number of electron into anion is equal to sigma of atomic number of atoms into atomicity plus n into mole of anion into negative Avogadro number. Here is the difference is the plus minus. Here we plus this and here we minus this, and and here we add, here we multiply with cation, here we multiply with anion. It is the same thing we can do. Now come to charge of ion. For finding charge of ion, like suppose cation or anion or neutral given, not for total change in Coulomb, for finding total ions we have to do n into 1.6 into 10 to the power minus 19 into mole of ions into Avogadro number. Mole in terms of volume of gases, it is a very important topic we have to see, and it also comes in gaseous states in a big manner. So let's do it quickly. We have an ideal gas equation, that is PV is equal to nRT. This ideal gas equation followed by every gas that does not have do the chemical complexion. Here P represent pressure, V represent volume of gas, T represent temperature, and R is represent universal gas constant, which values like 0.0821 something, and N is equal to number of mole of gases. Here N is equal to P into V, pressure into volume upon R into temperature, and V is equal to nRT upon P. It is V. These are very important equations. One formulas, okay. 1 mole into is equal to 22.4 liter at STP. 1 upon 2 mole is equal to 11.2 mole 2 liter 11.2 liter at STP, and in STP temperature is equal to 273.15 Kelvin, and pressure is equal to 1 bar or approx to 1 atmospheric AAT. and 2 mole is equal to, basically we multiply it by 2 into 44.8 liter. And for finding number of mole, we have to do V into B upon R into T, or volume of gas at STP upon 22.4 liter. Okay. 1 mole ideal gas occupied is equal to 22.4 liter at STP. In 1 mole ideal gas, 1 mole ideal gas occupied 22.4 liter at STP. Okay. Here mole is equal to vapor into density also. Vapor in density, and there is also a term NTP. It is very important. Which full form is normal temperature and pressure. Here temperature is 20 degrees Celsius and pressure is equal to 180. And for finding number of mole, we have the list formulas. All the number of molecules upon Avogadro number is equal to also mass in gram upon molecular weight. This all is applicable for every, like solid, gas, liquid, for every state. And for gases only, there is some specific state manner to find number of mole, that is P into B upon R into 2, or volume of gas upon volume of gas at STP upon 22.4 liter. Only gas phase is available applicable, only it is applicable for only gas phase and only at STP. And for finding mole, for mole, when we multiply mole into molecular weight, we find mass of substance. And where we multiply mole with Avogadro number, we find number of molecules. And when we multiply mole with 22.4, we find volume of gas at STP. So thank you so much, and this is the end of the video, and its second part will also come with some famous questions and also from PYQs. And till then, goodbye, tata. Don't forget to subscribe and share, because it will be very helpful for you and can be something masterpiece for someone who does not have money to pay, and you can help him. Thank you so much.